Hello, Form 2 students. Welcome to our mathematics lesson. And today we continue with our topic, surface area. Today we'll be concentrating on the surface area of a frustum of a cone. I'm your teacher, Mr. Wanyoike from Mary Hill Girls High School. You're welcome. This is our lesson number 4, and we continue with our objectives. We are now in objective number 4, where we'll be looking at the surface area of a cone frustum. If a cone is truncated somewhere or near the top, then the remaining lower base will form a frustum as shown in this diagram. The next diagram, we have an illustration of the same cone that has been truncated such that you have an upper part containing the apex or the vertex, and you also have the lower part that has the base, and that we'll call it a frustum of a right cone. A bucket of water is a good example of a frustum of a right cone. Let us now look at the dimensions of the truncated cone or the frustum or the shape of a bucket. In this case, we have a bucket here that is put upside down or a lampshade. Now, the original cone had a base, and that one you are going to label it with a radius capital R as shown in this diagram. The full cone, before it was truncated, it had a height, and we shall label that as capital H. The complete cone, before it was truncated, it had a slant height that we shall label it as capital L. And when we have the truncated cone that has the vertex, or the smaller cone that has been chopped off from the bigger one, then the smaller one will have a small r as the radius of its base, a small h for its perpendicular height, and a small l for the slanting height of the smaller cone that has been chopped off. So we shall be using a comparison of these measurements because they form a ratio, since the angle at the vertex has an effect on the ratios, and therefore the ratio of capital R over the small r then will be the same as the capital H over small h. Or in other words, we can put it the other way around and say small r over big R or capital R is equal to small h over capital H, which is equal to small l over capital L, where R or small r is the radius of the smaller cone that was chopped off. Capital R is the radius of the base of the original cone or the remaining frustum base. Small h, we have said, is the vertical or the perpendicular height of the cone that was chopped off. The same thing with the L. The small l is the slanting height of the smaller cone, and the capital L is the slanting height of the original cone. So we shall be using this relation to find any missing side or measurement in a frustum. So we shall do that in our next example. So in this example, we want to get the surface area of the frustum, the one shaded in yellow. And it has the points A, P, D, B, Q, and C, where PD is the radius at the top or the radius of the smaller cone. And we shall use continuous line or broken line from D to V and from A to V so that we can have a clear picture of the whole cone, how it was looking like. So in this frustum that is shaded in yellow, then we have the measurements 4 centimeters, that is PD. We also have 8 centimeters. 8 centimeters is the big R. 4 centimeters is the small r. The length PQ, we can label it as x, so that the perpendicular height of the whole cone before it was chopped off would be 12 plus PQ, or 12 plus x as the capital H. Then the small h is 12. That's the length from P to V. From P to V. So we shall use the relation small r over capital R is equal to small h over capital H, which is also equal to small l over capital L. The perpendicular height of the frustum, we can label it as x, so that anytime we have small h plus x, that will give us capital H. Small h plus x will give us capital H, or the height of the whole cone before it was chopped off. In the next example, we'll still continue this diagram and try to find the surface area of this frustum. Learner, the question can be, find the surface area of the solid below. The solid is the one we were discussing in the previous page, the one painted in yellow, which is a frustum. In this frustum, we are going to use the relation we have come up with, which is small r over capital R is equal to the ratio of small h over capital H, which is equal to the ratio of small l over capital L. Let PQ be x. This is the perpendicular height of the frustum PQ, be x, such that capital H now will be 12 plus x, 12 plus x, where capital H is now the perpendicular height of the whole cone before it was chopped off. So we equate that to the relation we have, so that small r, which is 4, divided by capital R, which is 8, these are the radiuses, or the radii, is equal to 12 divided by capital H. Remember, our capital H is 12 plus x. So we say 4 over 8 is equal to 12 divided by 12 plus x, which is the same as small l over capital L. So we pick the first two ratios to find the value of x. We say 4 over 8 is equal to 12 over 12 plus x, where 4 is the small radius, 8 is the capital radius, 12 is the small h, 12 plus x is the capital H. So when we simplify that, you get that x is equal to 12, which means capital H is 12 plus 12, which is equal to 24. Small height was given, which is 12. Small radius was given as 4, and capital radius was given as 8. Meaning, now we can get our L, the small l and capital L. Remember, capital H and capital L are sides of a right-angled triangle, and we can use Pythagoras theorem to find whatever is missing. So capital H and capital R already are the two sides of a right-angled triangle. So we can use Pythagoras theorem to get the missing side L. So we'll say small l is equal to small h squared plus small r squared, and then you get the square root of that. That is, small l is equal to the square root of 12 squared plus 4 squared. That is the Pythagoras theorem, and it is giving the value of small l as 12.6491 centimeters. You do the same for capital L, which will be the square root of 24 squared. Remember, this is the capital H, plus 8 squared, that's the capital R. So we say capital L is equal to the square root of 24 squared plus 8 squared, and that will give the value of capital L as 25.2982 centimeters. Now, to get the frustum area or the surface area of the frustum, we need to say it is the surface area of the big cone plus the surface area of the small cone. Remember, these are the curved surface areas. The curved surface area of the bigger cone minus the surface area of the smaller cone. Remember, these are the curved surface areas. And then, because they're solid, we remember to add the circular base and the circular top together. So in other words, the total surface area will be the curved surface area of the bigger cone minus the curved surface area of the smaller cone that was chopped off. And then this frustum has got a base with radius 8 and a top with radius 4. So we are going to sum up the 4 sectors to get the total surface area. And we have our formula. The curved surface area of a cone is given by the formula pi RL. So we are going to use this one. And also for the circular parts, the formula is pi r squared. So we say it is pi capital RL, that is the bigger cone, minus pi small rl plus pi capital R squared plus pi small r squared. And when we evaluate that, you get the figures for the first one to be 635.8131 plus 158.9532 plus 201.0619 plus 50.2655. So the total surface area will be 1046.0937 centimeters squared. 1046.0937 centimeters squared, correct to 4 decimal places. Learner, you can go through the example again so that you understand better. Here is your class assignment. Do it diligently and post your work to the Google Classroom platform. Question 1 reads as follows. Find the surface area of the open containers given below. Then number 2, it says that you find the surface area of the solids given below. Find the surface area of the solids given below. Read the instructions carefully, study the diagrams or the illustrations carefully so that you're able to understand everything. In case you have any question, we have numbers in the next slide. You can contact us. Have a blessed day.